Good evening to all of you. Good evening to all of you, my dear. Please let me know whether my voice is clear to all of you or not. Please let me know whether my voice is clear to all of you or not. It's clear? Okay. So, till now, whatever we have discussed, हमने अभी तक जो बातें कर ली थी वो हमने चैनल ज्योमेट्री वाले पार्ट को अच्छे से समझ लिया. हर एक सेक्शन का चैनल ज्योमेट्री वाला देख लिया. आर और डी निकालना हमने अच्छे से सीख लिया. ओह, बाय द वे, it's English class, sorry. So what we have done, we have completed channel geometry part. We all have understood how to find out R and D for different section, whether it is a rectangular section, triangular, trapezoidal, or any type of section. You are easily going to find out R and D. We have also discussed about classification of open channel flow, then difference between the pipe flow and open channel flow. So these things we have already discussed. Now today's I think it's the last class for introduction part, because from Monday I will be starting hydraulic efficient channel. So first thing as a basics which we need to study here is the Froude number. You know that open channel flow is something which is governed by the gravity forces. So in that case, Froude number is very important. Next, we will also discuss little bit about Reynolds number. Then we will discuss Chase's formula. Then we will discuss Manning's formula. In Manning's formula, we will also discuss about Stiegler equation and Meyerhof equation. And the last which we will discuss about is the convenience of the open channel and section factor. And section factor. So these are the topics which we are going to discuss in this class. So let's start with the first thing. That's something we call as Froude number. Now Froude number is actually a dimensionless number. It is actually a dimensionless number. So what is the meaning of Froude number? It's a ratio of inertial force. It's a ratio of inertial force divided by gravity force. It's a ratio of inertial force divided by gravity force. So Fr is equal to inertial force. If you write Fi, it is nothing but rho a v square. Already I have discussed this part with you. Rho a v square divided by gravity force, it will be nothing but mg. Okay. Now here if you notice, my dear, Fr equal to root under rho a v square. Now mass I can write as rho into volume. I don't think so anybody will have any problem, into g. Now you know that Fr is equal to area and volume. If you want to cancel, you can cancel out. Rho and rho will get cancelled out. So you will have V root under G into, if you will divide area, if you will divide volume by area, some D type of thing, that means depth type of thing will come, and that D we are naming it as, the same D is nothing but the hydraulic mean depth. Now you know that for each and every section, hydraulic mean depth will be different, and this becomes formula for the Froude number. where V upon root under GD, V is the velocity, G is the acceleration due to gravity, and D is the hydraulic mean depth. Now hydraulic mean depth value will be different for different section. Okay, is it clear to all of you till here? Is it clear to all of you? Okay. So now definitely a question comes in your mind, sir, why we have given a new number, something like Froude number. So basically it's a dimensionless number. And see, whenever we derive a dimensionless number, now whenever we have generated a dimensionless number, it is for the classification, it is for the betterment of the fluid mechanics, I will say. So in that case, even the Froude number is also useful. Look at here. If Froude number is equal to 1, we call it a critical flow. Critical flow. If it is greater than 1, we call it a supercritical flow. And if it is less than 1, we call subcritical flow. We call this as subcritical flow. So supercritical, subcritical. Supercritical, subcritical. FR greater than 1. So based on this Froude number, you can easily classify the flow. Na? So that is the beauty of this Froude number. That is the beauty of this Froude number. That is the reason we have given it just like Reynolds number. Reynolds number is also a dimensionless number. Now based on Reynolds number, easily you are telling this flow is a laminar, this flow is a turbulent, this flow is a transition. Easily you guys are telling. So just like that only, even Froude number is also a dimensionless number. And with the help of this, easily you can classify flow OCF into critical, supercritical or subcritical. Kindly note it down quickly. Okay. I think till now you have noted it down. Now, comparison of velocity and depth of subcritical and supercritical flow with respect to critical flow. So it's basically a comparison. Just you need to understand it first. For example, if you are telling FR is equal to 1, that means what? V upon root under. Let us talk about rectangular section. So in the rectangular section, D is equal to what? Y. Yesterday I have discussed this part. Equal to 1. So it is all about critical. It is all about critical because FR equal to 1, that means it's a critical flow. So V will be also VC, Y will be also YC. Now look at the subcritical flow. Here as you told, FR is less than 1. That means V upon root under G into Y, it should be less than 1. Now tell me, what are the conditions in which this value will be less than 1? Only two conditions is possible. Either your velocity will be less than critical velocity. That is the first condition to be subcritical flow. Another condition will be when your denominator part will be more. Either your numerator part will be less than the VC part, or either your denominator part will be more than this part. That means Y will be greater than YC. So in these two conditions, you will be getting this value less than 1. Is it clear? Is it clear? And these two conditions become a condition for the subcritical flow. Like whenever you are seeing your depth is more than the critical depth, you call it a subcritical flow. Whenever you say velocity is less than the critical flow, less than the critical velocity, you call it a subcritical flow. Similarly, if you see supercritical flow, here Froude number is greater than 1. So V will be V root under G into Y is greater than 1. When it is possible, only two cases are there for us. Either your V will be more than VC, that means your numerator is more than this part, or second case, your Y will be less than the YC. And then again, it's a condition for supercritical flow. Then again, it become a condition for supercritical flow. I hope it is clear to all of you, my dear. Now, this supercritical flow we also call as torrential flow. And sometime also we call as shooting flow. Torrential flow as well as shooting flow. Similarly, the subcritical flow we also call as tranquil flow. Tranquil flow. Just a different name. Sometime the gate people, they will give you this type of name so that you will get confused. So just be clear about that. Subcritical, another name will be tranquil. Supercritical, another name will be torrential or shooting flow. Kindly note it down quickly. चलिए, next one is the Reynolds number. So this also we will discuss. Anyway, you know that open channel flow is based on Froude number, not on Reynolds number, but we'll discuss this also. Reynolds number is basically ratio of inertial force upon viscous force. It's a ratio of inertial force upon viscous force. Ab, if you see the formula, inertial force is rho a v square. Viscous force will be shear stress into area. So Re will be rho a v square. Tau we can write mu into v upon y into area. Here Re becomes rho, v will get cancel out, rho v y divided by mu. This is something I'm writing as rho VL upon mu. This is the formula which you all guys are knowing. Generally, we say Reynolds number is equal to rho v d by mu. That is for the circular section. For circular section, L is equal to D. And for non-circular section, L will be equal to 4R. R you guys are already knowing, area by perimeter. Area by perimeter. So this part you need to remember always. Why we need to study this Reynolds number in open channel flow basically? Because based on Reynolds number also we have classified our open channel flow. So greater than 2000 we call it's a turbulent flow. Then this we call as transition flow. Then this we call as laminar flow. Laminar flow. Laminar flow, transition flow, turbulent flow. Laminar flow, transition flow, turbulent flow. Kindly note it down. These all are basics basically. Without these basics, you will not be able to study any topic of open channel flow. So from Monday, like for every day, one topic will be discussed. Monday will be the hydraulic efficient section, then specific energy, then critical flow analysis, then channel transition. So like this, every day you will be having one topic. Okay. If you have noted, then we can proceed to the next part. Now the next topic is the Chase's formula. So Chase has given a formula for velocity V equal to root under C root under RS. C root under RS, where C indicates smoothness. Where C indicates smoothness. R already you guys are knowing. S is the longitudinal slope. S is the longitudinal slope. S is the longitudinal slope. If you want, you can derive also this formula. Very easily you can derive. Like you know this formula, na? HF equal to FLV square upon 2GD. Have you heard about this formula? Yes, definitely all of you have heard. So V equal to, you can write like this, 2GD into HF FL. So I'm writing this in different way. Here I'm multiplying 4. Here also I'm multiplying 4. So this becomes 8G by F. Let me write it clearly. 8G by F. I'm separating out everything. This becomes D by 4. D by 4. And this becomes HF by L. Clear? So now if you focus, my dear, this 8G by F is nothing but constant. Na? G is also constant. Friction factor is also constant. D by 4. You guys are already knowing D is nothing but root under. This I can write as R. Head loss by length. It is nothing but the slope. So you got a formula for velocity where C is nothing but the, here you can write C is nothing but root under 8G by F. So Chase's formula is basically V equal to C root under RS. But as this formula, again, a new formula also given by Manning's, that also we will discuss. So we are going to use Manning's formula only most of the time. But this also we need to study. So like if C is more, velocity will be also more. If more smoothness, more C value, more velocity. Is it clear? More C value, more velocity, more smoothness. Clear? Kindly note it down quickly. Kindly note it down quickly. Okay. Next formula is the Manning's formula. So this Manning's formula is basically empirical equation. V equal to 1 by n, r to power 2 by 3, s to the power 1 by 2. R and s already you guys are knowing. N we call as Manning's constant. Manning's constant. We also call this as Rogosity constant. Rogosity constant. So N we call as Manning constant or Rogosity constant. Manning's constant as and Rogosity constant. So that is the meaning of N. 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 Okay. So as it is a empirical formula, so this formula actually supports experimental results. That is the reason Manning's formula is mostly used. Like if somebody will give you a choice to choose Manning's and changes, so you always choose Manning's equation for the velocity calculation. Because it's an empirical formula, it gives value which is much closer to the accurate value. Okay. Now to find out n, to find out this Manning's constant, first of all this n indicates what? This n indicates roughness. N indicates roughness. That means if n will be more, your velocity will be less. If n will be less, your velocity will be more. Is it clear? Just opposite to the C part. Okay. Now to find out n, to find out Manning's constant, we have two Baba. One is a Stickler and second one is Marov, and they both have given formula. So Stickler have given formula n is equal to d50 to the power 1 by 6 divided by 21.1. Again, it's an empirical equation only, but this is something which you need to remember. Where d50 is particle size below which d50 is particle size below which 50% of the particle are finer. 50% of the particle are finer. And we are expressing this in meter. In meters. So D50 is equal to particle size below which 50% of the particles are finer, and that we are putting in meters. This is formula for Stickler. Another formula is the Mayer-Hoff formula. Here Mayer-Hoff given formula D90 1 by 6 divided by 26. So here again D90 is same, particle size below which 90% of the particle 90% of the particle are finer. Particle size below which 90% of the particles are finer. Particle size below which 90% of the particles are finer. Clear hai? Again, if you notice both the formula, Mayer-Hoff and Stickler formula, in Mayer-Hoff they have taken up to 90%. So if you like, for example, if you have to take average, if you have to calculate average for like maths marks in a class, if you are taking average by taking marks of 90% of the student, definitely it will give you more na, compared to the 50% of student. So in that case, Mayer-Hoff formula is giving you more, I will say more accurate value. So that is the reason I have written a note for this. Stickler formula is valid for nearly uniform material far away from the toe of a mountain. In fact, nearer to the mountain toe, heterogeneous mixture of particle exists. Heterogeneity of the mixture of various sizes taken care by the Mayer-Hoff. Basically, if you are taking 90%, definitely the more heterogeneity of the particles are taken care. So in that case, definitely Mayer-Hoff gives you more accurate value compared to Stickler equation. This part you need to always remember. Okay, sometimes this happens like in, like for example, in Stickler equation, a small concept can ask, like somebody can ask you this concept, like a site engineer, instead of using meter, he has used mm. Let us say in place of meter he used mm. Now whatever n he will get, that n will be a wrong value. So I'm writing this n is directly proportional to d50 to the power 1 by 6. Yes or no? So if I have to write n wrong by n right, it will be what? For n wrong, what will be the d value? It will be 1000. And for n correct, it will be actually 1 meter. Because instead of meter, he has taken in mm. So in that case, 1000 to the power 1 by 6. Amma. Okay. 1000 to the power 1 by 6. So n wrong upon n correct, we are getting around 3.16. If you find out 1000 to the power 1 by 6, roughly you will get that only. 3.16 you will get. So I think it is crystal clear to all of you. So what you have understood? If you need to compare between Chages and Manning's formula, if you have to choose between Chages and Manning's formula for velocity calculation, we always choose Manning's equation. But if in question itself they have given C value, everything related to Chages equation only, in that case you need to find out velocity with respect to Chages equation. But if they have given n also, we'll go for Manning's equation. Now, another thing, if you have an option to choose between Mayer-Hoff and Stickler, you always choose Mayer-Hoff. Because Mayer-Hoff is taking care of more heterogeneity of the particle. Definitely it will give you more accurate value compared to Stickler. Okay, now one questions come, Can we make a relation between C, that is a changes equation, the changes constant, and that is Manning's constant, F, that is friction factor. So already we have a relation which we have calculated, C and F. Already we have made a relation. Now only thing we need, only relation we need to make is between C and N. Let us see how we are making that. You all know this formula, na? V equal to 1 by N, R to power 2 by 3, S to the power 1 by 2. I think you guys already knowing this formula. No need to tell anything about this. Amma, where it went? Huh? Now another formula changes root under RS. Let us equate this equation. So this is equation number 1. This is equation number 2. Equating, or here I can write, I have a space. Equating equation number 1 and 2. So we have 1 by N, R to power 2 by 3, S to the power 1 by 2 equal to C root under RS. C root under RS. C root under RS. So 1 by N, R to power 2 by 3, S to the power 1 by 2 is equal to C root under RS. Now if you look at my dear here, root under S and root under S will get cancelled out. We are having C equal to 1 by N, R to the power 2 by 3 minus 1 by 2. So C equal to 1 by N, R to the power 1 by 6. This is the value of C we got. So we made a relation between C and N, and C and this also. So ultimately we made a relation between C and NF. C and NF. Ultimately we made a relation between C and NF. Ultimately we made a relation between C and NF. And see, many people have doubt na about this F. F we call as friction factor, bacha. We have another that is we call as F dash. It is coefficient of friction. And F is equal to 4 F dash. Basically, one is British concept, another is American concept, and they don't satisfied with each other. So they have given a different concept. We made a relation between both. So F is equal to 4 F dash. So whenever in question they have written friction factor, no need to multiply by 4. Directly you can use that as a friction factor. But if in question it is written coefficient of friction, you need to multiply by 4. This is a small doubt which generally students are having. Okay, so have you copied these two things? Have you copied these two things? Copy fast so that we can go to the numericals. Okay, so if you have noted down these things, we can go to the numerical part, my dear. So here is the first numerical for all of you. Try this numerical. I will be giving you 2 to 3 minute time to solve this numerical. Each and everything you guys are already knowing. Okay. So now look at the question part first. Normal depth in a wide rectangular channel. So if you notice, my dear, this is wide rectangular channel. How many of you have, just by reading this question, how many of you think that, okay, it's a wide rectangular channel, that means R will be equal to Y? If this thing coming in your mind now, that means you are revising everything in a great way, in an excellent way. R equal to Y. Now what they are telling, normal depth in a wide rectangular channel is increased by 10%. The percentage increase in discharge of the channel is. So ultimately, if you are able to make a relation between discharge and the depth, or discharge or with the normal depth, then your problem will be solved. Q equal to area into velocity. Q. What about area? Area will be B into Y. Velocity will be 1 upon N. In place of R, I am writing Y to the power 2 by 3, S to the power 1 by 2. Now look at, my dear. B is constant. N is also constant. Slope is also constant. So can I say this Q is directly proportional to Y to the power 1 plus 2 by 3? It will be 5 by 3 if I am not wrong. Vandana Jain Sling sir, only one watching. What all you? It is so good. Thank you, bacha. Okay. Now if you look at, my dear, first we have first case like Q1. For Q1 it will be what? K In place of y, I am writing a 10% increase, so it will be 1.1 y to the power 5 by 3. Okay. Now percentage increase in discharge, if somebody is asking you, so that means q1 minus q divide by q into 100. That is the percentage in discharge. So k anyway it will be constant only. So I can write it as 1.1 1.1. Q will be anyway it will be get cancel out. So 1.1 to the power 5 by 3 minus 1 divided by 1 into 100. Q1 value I have put as k 1.1 y to the power 5 by 3. Q value I have put as k y to the power 5 by 3. Those things which are common in numerator and denominator, that thing will get cancelled out. Only thing we are remaining with 1.1 to the power 5 by 3 minus 1 divided by 1. If you calculate roughly how much we are getting, calculator where it is, so 1.1 17.2 something we are getting. 17.2 something what we are getting. 17.2 something what we are getting. Okay, so that is the normal depth. That means final answer will be option D. Final answer will be option D. One more problem I think we can solve based on this. I think this equation, this question also we can solve. Everyone give a try. Okay, so any of you have not answered this, enough time I have given to you. Now again, it's a very wide rectangular channel. So again, R equal to Y, designed to carry discharge. So this is discharge per meter. That means small q is given as, small q is given to you. Design is based on the Manning's equation with the roughness coefficient obtained from the grain size using Stickler equation and result in a normal depth of 1 meter. By mistake, however, the engineer used the grain size in mm in the Stickler equation instead of in meter. Why? Same thing which I have told you during the Stickler equation explanation. What should be the correct normal depth? Okay. So let us do first thing. V equal to 1 by n, r to power 2 by 3, s to the power 1 by 2. This formula we guys are knowing. So what I am trying to do here, basically, I will be finding n wrong value, Manning's constant for the wrong part. And then I will convert this wrong value into correct with the help of that thing which I have given you. N wrong upon n correct will be equal to 3.16. So first of all, I am finding out wrong. So for wrong, in place of v, I am writing 5 divided by y equal to 1 upon n wrong. So normal depth for wrong part, this value we got 1 na. It is given normal depth as 1 na. Okay. R value again 1 to the power 2 by 3. Slope anyway we are not taking. So n wrong, how much we got? N wrong will be s to the power 1 by 2 divided by 5. This is something I am getting as a n wrong. So let us convert this n wrong into n correct. So we know n wrong upon n correct is equal to 3.16. So n correct will be n wrong divided by 3.16. That means s to the power 1 by 2 divided by 5 into 3.16. Now see this formula, we can use it. V equal to, so V equal to, we have 5 divided by 1. So yn correct we don't know. 1 upon n correct we know. So it will be s to the power 1 by 2. And on top it will be 5 into 3.16. Then again yn we don't know. 2 by 3. Slope s to the power 1 by 2 we know. Slope and slope will get cancel out. 5 and 5 will get cancel out. What we are remaining with here, 1 upon 3.16 is equal to yn to the power 5 by 3. So you can give me the yn value after calculation. So it is 1 upon 3.16 to the power 3 by 5. So we are getting 0.5 meter. 0.5 meter. Yn is equal to 0.5 meter. This value what we are getting. Okay, so this is very important. By the way, this concept is very important. Like here they are telling instead of meter they have taken in mm. So in that case, n wrong upon n correct we have taken as 3.16. But if it is in meter, instead of meter they have taken in centimeter. Instead of meter they have taken in some other units. So this type of questions can be formed. Like different type of question can be formed, and for that this constant value will be different. So that you need to always remember. Okay, one small thing I will be discussing and then we'll close this class for today. Next class I will be starting with the hydraulic efficient section. Two small point. First one we call as section factor. So that is z equal to a cube upon t to the power 1 by 2. A is the area, T is the top width, and section factor is, it is like section factor we have now. Section modulus we have in RCC and all. So there section modulus indicate or represent strength. Here also the section factor indicates strength of the cross section. Convenience of open channel is basically, for example, Q equal to area into velocity. So Q equal to area, we can write it like B into Y into 1 by N R to power 2 by 3 S to the power 1 by 2. So if you write Q root under S, we have area. If you write only area, R to the power 2 by 3 N. Area R to the power 2 by 3. So Q divided by root under S, Q divided by root under S, A R to the power 2 by 3 divided by N. A R to the power 2 by 3 divided by N. So in that case, if you see, my dear, this part we call as convenience of open channel. Convenience of open channel flow. This part we call as convenience of open channel flow. This part we call as convenience of open channel flow. Is it clear? Is it clear, dear? Is it clear to all of you, dear? So Q divided by root under S is equal to A R to the power 2 by 3. A R to the power 2 by 3 divided by N. This is something we call as convenience of open channel. This is something we call as convenience of open channel. This is something we call as convenience of open channel. Clear? So in today's class, up to this only we'll discuss. Next tomorrow, Monday, next Monday, na? So Monday we'll be starting with a new topic, that is a hydraulic efficient section. That is very important topic for all of you. I will try to complete that topic in a single day for all of you. Okay. Thank you everyone. We'll meet on Monday at 8 p.m. sharply.